In this modern C++ series, this is a continuation of previous part 2 recording on the move semantics topics, where I talked and explained copy assignment operation. Here I will build on the same topic and the same code and explain move assignment operation. This is the code I have to discuss move assignment operation. This was the outcome of the previous recording. If you watch the previous recording on copy constructor, copy assignment particularly, then it will be easy for you to follow through this recording. But anyway, I will try to explain quickly what I have here, and then I will build on that. I have a student class with the attribute pointer and number of marks. I have a custom constructor to receive the data in the array and copy data into the this attributes. I have a copy constructor, copy assignment operator, and this is a function for displaying the data, and this is the helper function that actually calls this function to display the data. And because of this function, we are able to put this insert this student object into cout in this using this syntax. These are three objects created by passing to these three arrays, marks arrays, and copy assignment operation invocation and the output. I mean the display of the particularly this ht3 object after the assignment is completed. This is the output. Previously the S1, S2, S3 contain this data, and after assignment this S1 data is actually copied to S3 data. Now to talk move assignment, what I can do, for example, sometimes if you copy this S1 will retain its dynamic memory or resource, and S3 will have its own resource created. Sometimes you may not need this S1 object to retain that memory space. You may not be using that anymore, and in that case, instead of copying, you can actually transfer. You can actually transfer the ownership of that resource from ST1 to ST3, and that process is called moving. So in that case, you can do moving. So if I do have a statement like this, st3 equals to st2, in this case it will directly go ahead and call the copy assignment operator. And if I pass r value reference that I discussed in one of the previous recording, I can get r value reference of this object by passing it to move function, and now if I compile it the way it is, I don't have any move operator implemented. Let me quickly do the compilation and see what happens. There's no error. It is displaying the same thing. It is not displaying because I have not added the code to display there. If I, let's say, display after that, let me copy and paste it here and go back to the terminal and compile again. So it was actually the data was copy assigned from st2 to st3. Previously st3 carried this data, then after so that move assignment statement, it was actually copy assigned. So what actually happened is it searched the function and it didn't find the function which receives r value reference. So it went ahead and it actually invoked this function, the copy assignment function. So if you want this operation to actually behave the way you want, or actually move the resource, the ownership of the resource from this object to this object, then you need to define the move assignment operator. And you can do that as follows. Let me put move assignment operator after this copy assignment here. The syntax for move assignment is kind of similar to copy assignment with some changes. If I want to make this move assignment, then I cannot pass a constant, because actually when you move the resource from this object, then you are actually making changes to, so you cannot have this constant, and you want to receive that object as r value reference. So this is the syntax for r value reference. So now st will be r value reference to whatever actually is passed when this function is being called. So that is the syntax, and you have obviously return the current object, and also you have the guard against self assignment. But here what we do is if I want to transfer the ownership, then I don't need to do a lot of things here. I can just copy the st object's number of marks to the current object equals to st, and I can just copy the address. And after that, if you want to copy assign, first you need to release the memory. So max is actually, in this case, in our code, the max attribute of S3 is actually holding the data that is actually equal to the I mean it is pointing to the dynamic memory space which contains data which is equal to the dynamic memory space of data of the that belongs to the st1's max pointer. So you need to release that first, because you want to copy this st2 data, that means this data. Now it is currently st3 is holding this this data, and you want to release that memory space and allocate a new memory space, or you don't need to allocate memory space in the case of a move assignment. So first you delete marks, and then after that you just copy equals to st.marks. That means now current object's marks attribute is actually holding the address that source object's marks attribute is holding. Now you need to detach this source object from that dynamic memory space, because you cannot leave two objects pointing to the same dynamic memory space. So the way of detaching is set stmarks to null ptr, and then you actually set and also you set st, because this st object source object is not going to be used anymore, so you set it to the default state. So this is all you need to do. This statement actually does transfer of ownership. This statement releases the memory. This performs shallow copying. There's no deep copying in this case, and these lines actually set to the default state. Now with this change, the behavior of this statement should be different. Now what I expect is this S2 will not have any resource. It will be empty, and that resource would be transferred to st3, and the data the st3 will display will be exactly the data or memory space that actually will belonged to st2 before. So let me go to the terminal, compile, and see what happens. Now you can see previously this st2 object contained this data. This ownership of that memory space that contained data is transferred to st3. So now st3 is containing that data, and st2 doesn't have anything. It's empty. It's not a usable object anymore. So to explain this further, I'm taking you to here, move assignment. when st2 object is created, it actually it has a marks attribute and number of marks attribute, and marks is pointing to a dynamic memory space containing two marks values, 52.22 and 67.22, and number marks carried value 2, and at the same time st3 object carried the number of marks equals to 4, and it has a dynamic memory space which has a capacity to hold 4 marks values containing this marks values 51.11, 66.11, 71.11, and 76.11, and this marks attribute is pointing to this dynamic memory space. So all this data belong to st1 object. Now this data, the data on the lower part, they all belong to st3 object. Now when we execute this statement st3 equals to std move st2, then what happens here is, first it checks if st3 and st2 are not the same object. If they are not the same object, through this verification, then it will perform shallow copying of the number of marks. So 2 is copied here. Previously it was 4. So 2 is copied, and after that it deletes the marks, the dynamic memory space that is associated with st3 objects, and it detaches that memory, the memory of st2 object, I mean the marks pointer. It detaches the marks attribute of st2 object from its dynamic memory space, and it makes the marks attribute of st3 object to point to that dynamic memory space. So now at this point this dynamic memory space belongs to st3. It doesn't belong to st2 anymore. So st2 is actually set to the default state, marks set to null ptr and number of marks set to 0. So this is how this move assignment operation actually works. I think this is all I have to talk about the move semantics, move operation. Thank you for watching this video.